Real axis subset. For those of you that are not mathematically inclined, what is real axis subset? RRS is a set of objects on a numerical axis. Objects on numerical axis can be dots, which are represented by numbers, or intervals. And from intervals we recognize intervals with different kind of limits. So if the interval includes the limiting dot, call it segment. If interval does not include limiting dots, we call it interval and half segments. So in this case, -1 to -0.35 is interval, -10 to 10 is segment. Half segment is 2 and 2.5, closed on 2 and open on 2.5, meaning it includes 2 but does not include 2.5. Now that we know this, a good question is why we need this class, this module. You could do plotting in JavaScript, and it is very constructive to have operations on these kind of sets. Also, you could do some crypto experimenting, why not? Numerical analysis, and so on. Another use case is you can see schedules as objects on the numerical axis, because dates are represented by numbers. Therefore, if you have this universal class, this universal module that can add, subtract, or in general combine these kind of sets together, then you can combine, subtract, and add schedules together. You can do with this anything you actually want, if you need it. The point is, when you are writing a module, you don't make assumptions who is going to use this module. God forbid, make imports from the outside. This is very important design. How should our class look? Well, as I said, it should have set operations. Why don't we use a set? Well, let's see. If we use a set and add a number 5, then add this string. First of all, the set doesn't know that this string is actually an interval on the numerical axis. So we need to introduce a dependency that can parse this and handle this. Also, if we delete 7, this interval will not get split into half. It will do absolutely nothing, because 7 is not inside the set, and we quickly see that sets are not what we need. We need to make something else. Regarding this dependency that can handle intervals and set operations on intervals, you can download here, because I don't really recommend writing this alone. It is very tedious. It has many edge cases with all opened and closed limits. Therefore, I made over 1000 tests, and I will make more. Still not confident with this. Besides, it is a good practice to use already made dependency. This dependency, in short, as I said, had set operations over intervals and dots. And it looks more or less like this. As intuitive as it can get. Now that we know what we are making and why we are making it, let's see how. Let's start with an empty file. Define a type. This basic type is referring pure data. So the stuff that we can serialize and send over the network. We can recognize undefined as a subset of RRS. We can recognize a number, and we can recognize this tuple, which represents an interval, opening and closing limit, and if these two are included, respectively, first boolean for the first limit and second for the second limit. But I choose to write this in another way, like this. So I can document what each argument does. Little bit more lines, but no biggie. Then extend this data type with arrays of itself, because we want to process many data points once and define our class with its operations. We can add, we can remove, and cut. Add is union, cut is intersection, and not is minus. Here we write some JSDoc documentation that can actually parse a markdown syntax, which is very nice. Documentation says and states the class is stateful, means a lot in software design, and it is very handy to have this as first and most apparent thing. Then we document these functions and why we call them as we call them. Now, let's see how to implement this. Well, we need to route all these different kinds of arguments that we are receiving, numbers, arrays, tuples, and so on. This logic will keep repeating, so it is very smart to put it in one place and to reuse it. Let's do exactly this with this function. It is routing, and the interesting point is line 32. The end of its line, this boolean cast double exclamation point is casting our latest part of argument list as boolean in order to count the compiler. Without this, the compiler screams at us. Anything else interesting here? Well, the error in line 49. We don't have array of tuples, we have only array of numbers and intervals as state of our class. The interesting point here is we don't want to make and hold all these different kinds of data. When we receive these arguments, we construct them into intervals and hold these intervals as state. These are the only two types we need. After our routing logic is written, let's test it. After calling my RSS add to, we see the console. So the routing supposedly works. Let's continue. Since we can route, we can separate the functions. One that is adding a number and another that is adding an interval. Let's quickly introduce toString method in order to more easily control what is happening. Very good in combination with --watch, so you can see the changes instantly. Idempotency is ability to call a function or a method multiple times and yield the same result as calling it once. We want this for our add. So let's see finally how to add a dot or a number, because in this case these are the same. Let's first check if the number has an interval that contains it inside the RSS, and let's call this interval a father. If a number has a father inside, then we don't have to do anything because this number is already included. But if the number is not included, let's add it. So it's simple enough. We see that our interval here has this method includes dot, which can check if a dot or a number is included inside. Why this is needed is because limits may be included or not be included, and we don't want to deal with this from the outside. With log function, basically we don't want to repeat console log. Let's control in one spot how we log. Later form of this function is more sophisticated. We could pass an array of functions inside with log and then invoke each function when we want. But I decided to go with these issues. Each issue is issue for operation, and we route these issues very simply with one line. My RSS issue of 0 is operation name, and issue of 1 is the argument we pass. Then we sort because we want easy read in the log, and we finally log. So with only one enclosing in braces, we get logs for each of these issues. Very clean. If there is an interval that includes our interval, almost the same as for dot. If there is a father of our interval, we don't have to do anything. And here is a little different approach to test this. We filter intervals and we try to find if some of them includes him or not. Then we need to find all the intervals that intersect with our interval. All intersections we reduce with union, because the interval that we are adding is being united with all the intervals it intersects. So in two lines we do this: find intersections and reduce them to unification. Then we push this unification into our element list of RSS and remove all the intersections. After this, remove all the dots that are included in the resulting unification. And more or less we added an interval. Let's test this. With log, this is old with log, not the more sophisticated form. By carefully reading the logs, more or less we see this works. How to cut a number? Well, it's one-liner, so I will include it here. Simple enough. Let's extract this include dot method, because we need to check this in multiple places. Cutting can result in undefined, so we need to filter out all the undefineds. After mapping all the elements to the appropriate cut, this is everything that is needed by cut interval. For not a number, we check if a number is included, and we rely that no interval contains this number, so we only remove this number. But if the number has a father, we need to split it. Now, here is a discussion. If a split of father is array, and it is, if it is not a limit dot, then we need to spread. This part here saves us an extra line of code. And since we have an index and we are replacing one element with new element or more new elements or zero new elements, we are using splice instead of simple array assignment. Testing this looks satisfactory. For not interval, nothing new to see really. Remove the dots and remove intervals and parts of intervals. Now, of course, some additional work is needed here, mainly testing, and it would be nice to parse a string input. If you want to see the actual coding and me hitting all the errors and fixing them, or you want to code along, check this out. Content of this video is good exercise. Until next time.